Hello, welcome back to Math with Patrick. It's June 12th, and we're solving problem number 163 from the Daily Epsilon calendar. And let's show why x needs to be 12 degrees today. And honestly, the solution here is pretty quick. Basically, I'm going to use the interior angle sum theorem, which basically states that all of the interior angles of a polygon are going to sum up to some multiple of 180. And for quadrilaterals, or four-sided shapes that we see here, specifically it's going to be 180 times 2. And so I'm going to solve this problem pretty quickly, but I think I do want to chat about where this angle sum theorem comes from. And I think I want to try two different ways to prove that it's true. And so here I'll actually kind of write out what the theorem would look like. It would be some kind of multiple of 180, and specifically I'm going to do times 2. And it's always going to be the same number of sides as your shape there, so that 4 kind of lines up with the fact that we have a quadrilateral, and you're always going to subtract 2 in this theorem. So ultimately, I'm going to get 360 is the sum of all of these other angles. I think it might be convenient to sum up these 3 first. I see that we have a 348, it looks like. And so when I add x, I should get 360. And if you subtract 348 from both sides, you're going to pretty quickly see that x has to be 12. And that's today's date. So that's a whole solution. Hooray, we did it. But I do want to chat a little bit more about that interior angle sum theorem before we go. So that's what I'm going to talk about now. Way number 1 to prove it is to study triangles, actually, and to convince ourselves of the triangle angle sum theorem, or interior angle sum theorem, where if you add up the angles in a triangle, we're going to get 180 degrees. Usually in geometry, you just kind of accept this as a fact, but I do want to have some kind of explanation as to why this is true. My favorite way of kind of convincing myself that this is true is to think about a triangle as part of this kind of parallel line scenario. And whenever you have parallel lines and a transversal, that is a line crossing the other 2 parallel lines, you're going to find a lot of congruent angles. These are going to be alternate interior angles. The alternate part is because they're on alternate sides of the transversal, and the interior part just means that they are on the inside of my parallel lines. And alternate interior angles are always congruent when you got parallel lines here and here. And so I think we're going to have another pair of alternate interior angles here and here. And then finally, I'll just color this middle one in blue. And so it's a pretty well-known fact that 180 degrees makes a line, because 360 goes all the way around the circle, so half of it would be 180 degrees. And so from this diagram, you can see that these make 180 degrees. And therefore, you should be equally convinced that the 3 angles on the inside of this triangle too make 180 degrees rather. This proof isn't rock solid, right? Because maybe stuff would look a little bit different if I actually had an obtuse angle in there, or maybe it wouldn't be different at all. And so this is just kind of a geometric explanation rather than a rock solid proof. Regardless, I feel like this kind of shows that triangles sum up to 180 degrees. Now, if we take a polygon, let's just use a pentagon as an example. And if we want to know the sum of all the angles, all the interior angles on this polygon, we can draw some triangles to just kind of figure out that interior angle sum. So I'm going to draw my triangles like this, and you could convince yourself that, these 3 angles here are going to add up to 180 degrees. Then these 3 angles here are also going to add up to 180 degrees. And then finally, these 3 angles here are also, once again, adding up to 180 degrees. And the reason why I'm drawing these with arrows is as you kind of walk your way around the pentagon, you'll notice that all of these angles are going to perfectly add up to get all the angles, all 5 interior angles in the pentagon. So for this one, we would do 180 degrees times 3 because we have 3 triangles. And so this 3 is kind of coming from the idea that we have 5 sides and we're subtracting 2. So here's one explanation as to why this interior angle sum theorem works, is that you can take up any polygon and subtract 2 from the number of sides to draw the right number of triangles, and then you multiply it by 180 degrees to get the total sum. Again, not a rock solid proof, right? This right here looks basically like a regular polygon. Like all the sides look the same, all the angles look the same. Maybe my kind of visual proof would work a lot differently if I had some kind of concave polygon. So, not a proof, but just a really good explanation for now. My second way to think of this interior angle sum theorem is to actually study the exterior angles of polygons. And I think I'll use a pentagon also to just kind of prove my point here. An exterior angle of a polygon is going to be this one right here, where you kind of extend the line segments and then you try to connect those back to the polygon. And all of these are going to be some exterior angles of my pentagon. And there is a theorem where if you add up all the exterior angles of a polygon, you're going to get 360 degrees. And the idea behind this is if you can imagine maybe translating all of these angle measurements into the center of the polygon, we are going to perfectly map out a circle. And so, this, like I was saying earlier, this isn't a super, super solid proof. But if you just kind of think about translating these angles from the outside in, we're creating a perfect circle, right? As we walk around this pentagon, we will have turned 360 degrees. We will have walked a whole circle. And so if you sum up the exterior angles in any polygon, it's always 360 degrees because you always do that full circle. And so what that tells us about the interior angle now is that since these make a linear pair, I can do 180 equals like inner plus outer, right? Because the inner and outer have to sum up to 180 degrees. That's a straight line. The outer angle, that was the one we were able to figure out with, 360 divided by n. I think because like n was the number of sides, and then 360 is just all the way around the circle. And I want to like isolate this this interior angle part, just because if I do, at least for this polygon, 5 times I, I'll get the total sum. So in general, it should be n times I for the total sum. And I'll write that here. S is going to be n times I, where n is the number of sides, and I is the interior angle of the polygon. So let's isolate I just so I can stick it in here and see what expression I can come up with for the total sum of all the angles in this polygon. Shouldn't be too hard. I think I'll just subtract this fraction to the left, and I'll kind of rearrange my equation so that I is on the left side. I'm going to get I is equal to 180 minus 360 over n. That was just me subtracting this fraction over to the left side. And in particular, I do want n times I. So I'm going to multiply both sides of this equation by n. And n times I is going to be exactly the same as just the total sum of all the interior angles. And that's going to be equal to 180 times n, because I'm multiplying the n to both of these terms. And then finally, the divide by n in the denominator here is going to cancel with this times n that I'm applying to both sides of my equation. So I'm just going to get minus 360. Cool. So the sum is equal to 180n minus 360. And if we factor out a 180 from both of these terms, we're going to get exactly the same idea as we got earlier with like splitting up some triangles on the inside of the polygon. So no matter which way you cut it, we're going to get the same interior angle sum theorem. It's going to be the same formula. And that's the formula that I used up here in order to say that 360 is the total number of degrees for a quadrilateral. All right, cool. Thanks for watching along and kind of listening to my proof of why I'm allowed to use this to get 360. Ultimately, that helped me get the 12 for today's date, and I'm all done. So thanks again, and I'll see you tomorrow.